Hello everyone, in this video I'm going to go over example 3 of weight-volume relationships. This example is pretty similar to the first one we went over, but the difference is instead of given the total weight, we are given total mass, and instead of looking for unit weight, we're looking for density. So for this example here, we have a moist soil sample. So we know there are 3 phases, and we're given the following: total volume 1.2 meter cube. We know the total mass, we know the moisture content, and we know the specific gravity of solids. And we're going to determine the following: moist density. So this corresponds to basically the moist unit weight. So we use rho m for moist density. Dry density, rho d. Void ratio E, porosity N, degree saturation, capital S, and the volume of water in the soil sample, V water. So the first step for to solve this weight-volume relationship problem is to draw the phase diagram. Okay, so let's get started here. So on this slide, I'm showing the phase diagram corresponding to a moist soil. So we have 3 phases. We have solid, water, and air. Okay, so we have the 3 phases. And for this example, since we're given mass, so one side of the phase diagram, I'm going to put mass instead of weight, so mass, and unit is kilogram. And on the other side of phase diagram, we're going to figure out the volume, which in this case is meter cube. So the unit is meter cube. Okay. So the first step, as I mentioned, is to draw this phase diagram. Then we are going to figure out mass and volume for different phases and complete this phase diagram. So for this example, we know the total volume is 1.2 meter cube. So that means we know its total volume. Capital V is 1.2 meter cube. And we know the total mass is 2350 kilograms. So we know the total mass is 2350. Okay. And then we also know the moisture content. So moisture content for this example, 8.6%. So we know that the definition of moisture content is weight of water, or in this case, mass of water over mass of solid. Okay. So then we know the total mass is mass of water plus mass of solid. Okay. So from the first expression, we have this relationship between mass of water and mass of solid. Okay. So then you can substitute mass of water into the second expression. We know the total mass is 2350, and mass of water is water content times mass of solid plus mass of solids. Okay. And water content is 8.6%. So we have 2350, and plug in 8.6%, that's 0.086 mass of solids plus mass of solids. Then solve for mass of solid. So this gives us MS of 2163.9 kilogram. Okay, so that's mass of solid. And then mass of water is simply moisture content times mass of solids. And if you plug in these numbers, you get 186.1 kilogram. Okay. And again, this is 8.6% or 0.086. Now we have the mass of water and mass of solids. So let's put them on this phase diagram. So mass of solids, 2163.9, and mass of water is 186.1. Okay. So we completed the mass side of the phase diagram. And then let's look at the volume side. We know the total volume is 1.2. And then For water, as I mentioned before, if we know the weight or the mass of water, we can figure out the volume using the constant density or unit weight of water. So in this case, we know the volume of water. So let's start with rho W. That's the density of water. As its definition is mass of water over volume of water. And then we can back calculate volume water as mass over density. Okay, and density of water is a constant. So in the SI unit, it's 1,000 kilogram per meter cube. So we have 186.1. So that's mass of water divided by constant 1,000. So this gives us 0.186 meter cube. Okay, so that's the volume of water. So here this is 0.186. And then for the volume of solids, and we're going to use the last given, which is the specific gravity of solids. So we know GS is 2.71, so that's given. And GS by definition is gamma S over gamma water. And if it's density, it's rho S over rho water. Okay. And this gives us, and rho S is mass of solids over volume of solids, then times mass density of water. Okay. So then we can figure out the volume of solids is mass of solids over specific gravity GS times density of water. Okay. And then if you plug in all the numbers, so we know mass of solids, we know specific gravity is given, rho water is constant, so we can calculate VS as 0.798 meter cube. Okay, so that's the volume of solids, 0.798. And then the volume of the air is basically the difference between these two. So you can calculate the volume of air as well. And for this problem, the volume of the void, so this is V sub V, is total volume minus volume of solids. So this is 0.402. Okay, so that's volume of solids. And then if you want, you can calculate the volume of air as well. So that's the difference between these two. Okay. You don't actually, for the quantities we're going to calculate, we don't actually need VA explicitly. We just need a V sub V, the total volume. But you can definitely calculate this as well. And that's 0.216. Okay, so that's volume of air. So now we have this phase diagram completed. Then all the quantities we are looking for, they are just basic definitions. Okay, so if you look at the problem statement, we have 6 quantities that we want to calculate, and all of them are basic definitions. Okay, so we start with A here. So the moist density, rho m, is total mass over total volume, and this is 2350 over 1.2. So that's 1958.3 kilogram per meter cube. And then for the dry density, part B, dry density, again, basic definitions. This is mass of solids over total volume. So mass of solids, so we have, again, these are from the phase diagram we just completed. So 2163.9 over total volume 1.2, and that gives us 1803.3 kilogram per meter cube. Okay. And then part C is the void ratio. And void ratio E by definition is volume of voids over volume of solids. Okay. And volume of voids 0.402 divided by volume solids 0.798, and this gives us 0.504. And then porosity, N V sub V over capital V, total volume. So that's 0.402 divided by 1.2, and that's 0.335 or 33.5% if you want to use percentage. And part E, degree saturation, is V water, volume water over volume of voids times 100%. Okay, so that is 0.186 over 0.402 times 100%. So the degree of saturation is 46.3%. And then last one, the volume of water. And this is something we already completed on the phase diagram, 0.186 meter cube. Okay, so that is example 3 of chapter 3. Again, as you can see, the most important or the key step in solving this problem is to draw the correct number of faces on the phase diagram and then complete all the mass and volume for different faces. And once you completed that, the rest of the calculations are basic definitions.